This is a very short video to show you how to do the last page of the Basketball Earth Lab, page 6, where you've got to create this diagram. What we're trying to do is represent the layers of the Earth accurately by using the basketball as a model. What we want to do is create an accurate fraction of this radius of the basketball, this 12 centimeters or 120 millimeters, so that it represents a scale model of how much of the radius of the Earth the different layers would occupy. So I'm going to go back to page 5, and we need the table that's on page 5. And we're going to use this column of the table, the thickness on the ball. That gives the thickness of each layer. And hopefully you've already done this math. We're going to work from the center outwards, so I'm going to show you an example using the inner core. I've figured that the inner core should represent 22.8 millimeters of the radius of the Earth. And the way I've gotten that is that the inner core occupies 1,216 kilometers of the 6,371 kilometers of the radius of the Earth. So that fraction of the 1216 divided by the 6,371 kilometers is 0.19. In other words, the inner core occupies 19% of the radius of the Earth. If we take that 0.19 times the 120 millimeters of the basketball, you can see the multiplication over here, that's how I'm getting the 22.8 millimeters that the inner core should occupy of the radius. 22.8 millimeters is, of course, the same thing as 2.28 centimeters. There are 10 millimeters in every centimeter, and that's going to be a lot easier for me to work with. And I've rounded that to 2.3 centimeters. That's fine. You aren't going to be able to measure certainly to the hundredth of a millimeter, so rounding to the millimeter or to the tenth of the centimeter for this portion is fine. So now I'm ready to diagram this on the picture on page 6. So if we go back, the radius here, oops, get to the centimeter side. The radius of the Earth is being represented here by the radius of a basketball as 12 centimeters or 120 millimeters. We've said that the inner core occupies 2.3 of those, so you can actually do this much more carefully than I can looking through a camera. But what we want to do is go up to 2 centimeters to 1, 2, 3, 2.3 centimeters. Make a mark, and now it's up to you. You can either make the mark if you want to be kind of minimalist, or you can certainly continue this curve all the way if you like. You can color it in if you like, but it's good to put some type of label here. This is the inner core. And we'll move on to the next layer. I want you to actually do the math, but you can see that the outer core occupies almost twice the radius of the inner core. I'm going to estimate that the outer core occupies roughly 400 millimeters or 4 centimeters of the Earth's radius. And keep in mind when you measure that out that you want to work from the outer edge of the previous layer. So this doesn't mean 4 centimeters starting at the radius. That 4 centimeters that the outer core roughly occupies would be measured from the boundary of the inner core. So we'd move from the boundary of the inner core. We'd measure out 4 centimeters here. We have our next layer. And again, it's up to you if you want to draw this whole curvature and label it. Color it in if you want to get fancy, and make sure that you send a picture of this when you're done. Keep in mind that I've given you directions to lump together the radius occupied by the hydrosphere, crust, and atmosphere. And the reason is when you get way out here, all of those layers are so thin. That's really the point of the lab, that the portions of the Earth we experience are such a minuscule fraction of its total radius, of its total depth. Even if you lump those three together, I would guess you're going to come up with roughly a millimeter, which is very, very difficult even to show on this diagram. So good luck. I hope this helps.